Hi, everyone. From Sydney, Australia, I would like to present AML Compliance Assistant. It's a tool built to help people, professionals that work with AML. AML stands for anti-money laundering, and this particular work is as the foundation of the legislation in Australia, the AML-CTF Financial Act 2006. So anti-money laundering is a very complex legislation. It goes across many countries and there are many parts involved. And usually it's crafted with complex language made with lawyers. The legislation is made in parliaments. And this present work has the objective to deal with this complexity of the text. So this is the base document that this work is based on. It's the Anti-Money Laundering Financial Act. So I would just like to show just a bit of the document, the actual document. So it's this one, and it's the problem with the document is that it has lots of references to other documents. There is conditional legislation, like if something happens, then another thing must occur. Also, this document is periodically updated, and there is references to updates. So it's complex. Sorry. And this tool is designed to have an understanding of the document. And it's useful, can be useful mainly for junior lawyers or junior people working on this field, just to have precise information, just in a conversational manner, understand what's inside the document. These are a couple of things that this tool can achieve. Some are not quite actually developed in full. But like the simplification of legal text, have a quick reference on a particular item, the location of the item on the text, and have some reasoning about putting all the things together with information that is in the document. So I will do a quick demo view. So this is encapsulated in on Chainlit, and this is deployed on Hugging Face. So I have a couple of questions here that okay, probably this will take a little. One of the things about this is that the streaming option is not set up, so we are just seeing the questions in the at the end. So, and as you can see, so he actually bring some parts of the document and says where the specific parts are. I have some questions, other questions, like very simple, because so this, I will explain it a little bit further, but it has two tools, and the idea is to restrict the search on both those tools to anti-money to the subject, in order to not like hallucinate, because in this case it could be a little bit dangerous. I have other questions. Probably it's taking a little bit of time. Okay, so the idea is always search the thing in the document. Okay, I will explain this just in a moment. So after the demo, so I will now explain a little bit how this works. So this is a very simple use of just one agent that has the knowledge that he can access two tools. The tools is a vector retriever that's stored on disk, and it's inside it's based on the document, and web search. The web search is restricted, and I try to control it as much as possible to just search items in this space, in the AML space. So this is the usual flow chart. So it's made from Mermaid. The agent knows it has two tools. It will decide based on the query which tool to use, and it send to us the indication, and we make the use of the tools on our side on the software. And once it's satisfied, it will end and we'll present the answer. That's what we saw before. So it will just use a basic a retriever with embedding models, a vector database. We are using text embedding 3, the quadrants stored on disk, and we are also using the multi-query retriever that we noticed that we had better results using the GPT 3.5. The web search is just DuckDuckGo search API, nothing special, just using our region and Australian region. So in basically for this simple model, what will decide the quality of the answers and the boundaries that the system works, it's the descriptions of the tools, the description when to use the retriever tool, and the description for the web search tool. Also, the most important is the behavior of the agent, so the prompt that we will use for the agent. Okay, so now I will have a quick code walkthrough. So as I said, we are using Chainlit. The first thing we need to do is to split the document. So this is made in another phase. It's just a notebook. We are using the recursive text splitter. I tried different chunk sizes. This proved to be the best one, and we are just creating the Vector store and store it on disk. Nothing special. We just have to upload it to Hugging Face or to use when we are using the app. So the app is here. So this is here. I'm sorry. So very simple. This is the prompts. The prompts are very, very simple, and they must be worked on, and along with much more work. So this is the model used for the embedding models. For the embedding model, we are just here defining and instantiating the retriever tool, using the vector store stored on disk. We are just instantiating the graph, just a simple thing that we saw. We'll build the agent. We build the node with the agent and another with the action and conditional edges. So to have the flow chart, this is just an auxiliary message for debugging. And it's just this. So this is why this is so simple. And that's why we don't have streaming here. So we just only when it finishes, gets the response, it will show the response on the screen. Okay, so I'll be back. Oh, something is, sorry. Okay, so another important thing is that it was very helpful. It's Langsmith. I'm sure you guys know what it is, but I have another slide. I'm about about Langsmith. It's just a very useful tool. It's actually amazing. So all those prints are not necessarily needed except for faster. Sometimes this can be take a little bit more time. So just if you want to pinpoint specific information, but everything is here. So we have the request. This is the log of a request. We have that the agent asked to make a query to the search, and this is interesting here. So this was output from the agent. The agent said, with these questions, the agents decided to choose the retriever, and this was the query for the retriever. And we have the final answer here saying that it should end and finish the cycle. So okay, finally the right slide. So talking about limitations of the model, there are plenty of them, and one of them is just a one shot. We don't have memory, so it doesn't know what it's only one question at a time. So we have no streaming, and most of all, it's the situation of the validation. So unfortunately, we are not using Ragas. We don't have a proper data set. We started to use a data set from specialists on the field, but we didn't have it finished. That would be definitely the next step. Well, talking about next steps, so I will start with the conversation functionality, and one very important thing is the use of a multi-agent graph. So add more agents, and it's exactly what's written in here. So, and I think the best results that we could have is just like having one agent for each tool. So one agent is totally responsible for the tool and he's in full control of the tool. Because I noticed that with this agent, just one responsible for two tools is sometimes doesn't understand the instructions. Sometimes he search the web when he shouldn't search the web. It just should say, I don't know, because this is not part of AML. So, and that's the idea, to have at least two agents if we are using two tools. So one agent per tool, fully controlled. So about the data set, the validation. So we don't have, it's just like manual validation and people validation. I have some people are working with me and validating the results from the tool, but they are experts in the field, but it's totally manual. So we need it in the future to put this together and make an evaluation pipeline. And I think that's all. Thank you. Questions?